Okay, so number 1 says to give 3 properties of metals. They're malleable, they're good conductors, they're ductile, most are solid at room temperature. Any 3 of those things. Okay, an alloy is a base metal mixed with another element. Most of the time that other element is going to be another metal. Really the main exception to that is we see carbon mixed into things sometimes to provide strength. Mostly it's going to be metals. Alloys are prepared to change the properties of the base metal. I see a lot of people put to make it stronger. Well, that would be a specific property that you would want to change. But overall, we would say to change the properties. Physical properties, yeah. Okay, number 4 says name the 2 types of alloys and describe the composition of each. There's substitutional alloys and there are interstitial alloys. And physically the difference is the size of the atoms that we're putting in, but of course that is going to manifest itself in how they are arranged. So, I love how I'm explaining this stuff and there's conversations going on. It's not distracting at all. In substitutional, because they're mostly the same size, they will substitute for the atoms, and interstitial, they go in between. I guarantee that is something that you will have to know for the test tomorrow. In fact,
tomorrow, I'm not coming back.
Oh, good Lord. Isaac, do you know the definition of a pedant?
Nope.
Okay, that means a person that is overly concerned with everything being specifically, absolutely, technically right. Sometimes you just got to let it go, man. Obviously, I mean the next class period. So, on the test on Monday,
there we go.
There may be pictures there that show atoms either interspersed in between other atoms or substituting other atoms, and you will have to list whether that is a substitutional or an interstitial alloy. So make sure you know those.
Yeah, it is.
Okay, now here, yeah, I suppose it does have a little bit of tin. The main reason I had you do these is just to get in your minds that these things on the left, brass, bronze, nichrome, white gold, sterling silver, steel, stainless steel, are all alloys, okay? Because remember, on the test, I'm not going to go, hey, what things make up sterling silver? But I may ask you, out of these things listed, which of them are alloys? But again, that shouldn't be that hard, because if it's not on the periodic table, it's going to be an alloy. What's a periodic table? It's a unique way of making me feel like a failure. Thank you, Braden. Or, Bryson. Ooh. That was kind of harsh, man. Jeez. For the love of God. Okay. Let's talk about what you will have to be able to do on the test on Monday. Okay, number 1. Now, this shouldn't be bad because it's actually a throwback to the last chapter. We learned in the last chapter what an ion is, and we learned the difference between a cation and an anion. So remember, an ion is just an atom with a charge because it's either lost or gained electrons. It has to be electrons. Protons can't move without changing the element. And that doesn't really happen, except in radioactivity. Okay, so ions are charged atoms. They either have more or less electrons than protons. And, of course, we can break those down into anions, which are negative, and cations, which are positive. Yeah. Yep. And we should also know which one of those has gained electrons. The anion gained electrons. Remember, don't fall into the trap that gaining means getting more positive. We're gaining negative charges. Losing negative charges makes you positive. Yep. Actually, that's from the Return of the Jedi. Dude, don't even. Yes. So when they show up at the second Death Star, think the generator's going to be down. The fleet's on the other side of the moon. All right. Number 2 says be able to predict the charge of different monatomic ions and explain the movement of electrons to form specific charges. So there's a lot of words here, but this isn't as hard as it sounds. Basically, I'm going to say, hey, what charge would we expect oxygen to have? And so we look on our periodic tables and we go, okay, these should be all -2, right?
Okay, I get it.
Now, here's the thing. You will have a periodic table on the test on Monday. It will not have the charges written above. So you need to study your periodic table and know that these are +1, these are +2, +3. Don't ionize, right? So we skip over that one. These would be +5 or -3, -2, -1. And remember that these plus tin and lead are varying charge, but they're always cations. What? Depending on what you're mixing it with. If you're mixing nitrogen with something that always forms a cation, then it would have to be the -1 because negatives and positives have to go together. If you're mixing with nitrogen with something that's always an anion, then it would have to be the positive one. I'm sorry. I can't do anything about that fact. That's just the way it is. Okay? So the big one to remember, tin and lead, right, don't go along with this column. They do ionize. They form cations. The rest of them in this column we say don't ionize, but tin and lead do. We just don't know what their charges are because they vary. Okay, number 3 says explain how ionic bonds number 2, going along with that, for oxygen, for example, we should be able to say it's going to gain 2 electrons. That's what makes it have the -2 charge. For magnesium, we should say it's going to give up 2 electrons. That's why it has a +2 charge. Aluminum gives up 2 electrons. If I say, hey, you've got a lead you have a lead cation with a +4 charge, what happened to the electrons? You'd have to say it gave up 4 electrons. That's why it has a +4 charge. All right, moving on. Number 3 says explain how ionic bonds form. So remember, ionic bonds really come down to the fact that when you have a cation and an anion, they're attracted to each other because they have opposite charges, just like opposite ends of magnets are attracted to each other. So the ionic bond comes from the attraction of the positives and the negatives of the cation and the anion. Okay. Number 4 says you should be able to write formulas of ionic compounds. So that's the thing that we practiced, for 2 days. We did that whole big thing where we put the ions together, whether they were polyatomic or monatomic. So there will be, monatomic just means one of each instead of a polyatomic ion. Right, so each ion only has one atom. That's where the 1 comes from. Okay, so for example, if I give you and I say write the ionic formula for a compound compound between aluminum and nitrogen, what we need to first do is figure out the charges. So aluminum would be -3+. Nitrogen would be Okay, so it's plus 5 or minus 3. All right, Brooke, here's where you need to, where this comes up, right? It's either plus 5 or minus 3, because these in this column right here are plus 5 or minus 3. Oh, sorry. Yeah, so the point is, it can't be this because it wouldn't form, right? The whole point is this has to give up electrons. The nitrogen will have to take electrons. It can't be a positive charge. So in this case, yes, nitrogen could be either one of these, but in this case with the aluminum, it has to be the minus 3. So what would be the formula for aluminum nitrate? Oops.
Shoot it.
Pick it up.
Knock it out. Punch it in the face. Knock it out.
So the person who is the mother of this did not give you instructions. I'm going to have to make sure that I thank Mrs. Oakes for this experience. Remember, this is a good example. If you do the cross-down method, you have to reduce, right? So if you do the cross-down method, that is fine, but make sure you reduce it. Where is the off switch? Oh, here we go.
Careful, it was his neck. It falls back very fast. You can't push his neck.
Okay, let's move on. Number 5 says you should be able to explain what a polyatomic ion is.
That's the big one?
Now remember, a polyatomic ion... A polyatomic ion is a bunch of atoms connected together that create an ion itself. So instead of just having one atom with a charge, we have a bunch of atoms all tied together, and together they have a charge.
So a bunch of atoms that connect together?
Yes, that have a charge. Most polyatomic ions, of course, are negative. You have your polyatomic ion sheet. So, for example, form an ion. So, for example, well, it's not a baby. It is a machine. I was looking for the off switch. I need one of those keys. So, phosphate is a polyatomic ion, right? There's 4 oxygen and 1 phosphorus, and when they're all bonded together, they're bonded in a way where they are able to accept 3 electrons. So they will end up having, all together, working together, they will have a negative 3 charge. Now, overall, it doesn't work any different than, say, nitrogen, right? If we had phosphate here instead, it would still accept 3 electrons from the aluminum, and you would have 1 of each. The thing that is a little bit confusing is there are more than one atom in here. So we have to treat this as if it was one thing. Okay? But one thing, if you're really getting confused about it, one thing that you can do is put an X in for it. So, for example, if we were going to put this with, say, magnesium, right, which forms a 2+ ion, put an X in it with the charge, figure out what it would be. So if we use the cross-down method, we know it's going to be Mg3X2. And then for the X, substitute in the actual ion. So this, we would write Mg3PO42. It's just we have to have the parentheses around it to show that group. Okay? Because this thing right here, even though there's 5 total atoms there, it doesn't work any differently than a single atom with a -3 charge as far as how it goes into a compound. Just got to be careful with those parentheses so that we're showing the right notation. Now on the test, you will have one section where you have just singular atoms off of the periodic table where you have to put together to make polyatomic ion formulas, or sorry, not polyatomic ion formulas, ionic formulas. Then you'll have another section separate where we will do polyatomic ions. Okay? Those polyatomic ions, you will have to look up their charges on the polyatomic ion sheet. So that on the test on Monday, you will have a polyatomic ion sheet with your periodic table. That's where you go to find the charges. It's hard not to be in this class. Okay. I mean, here's my question. Since, Allie, that is not your child, why is it in our class instead of in the class with the mother? I don't have experience with machines. I have experience with real children. No. There are obvious cues as to what is wrong with the baby other than it's just making noise. Okay, number 6. You should be able to explain disassociation, which most of you should probably be confused about because looking back I realized that I forgot to actually use the word dissociation when we talked about that. So, here's some new learning. Oh. Because listen, we already learned about this. We just didn't apply the term. Disassociation is when a solvent breaks ions apart. Yes. Remember when we learned about how when we put salt in water, the water actually takes the sodium and the chlorine and separates them. That's disassociation. So disassociation is just when a solvent like water would be the solvent in this case, so let's put water above this because that usually is going to be the solvent. So because salt is an ionic compound, water can actually separate the ions into the cations and the anions and surround them differently. That's disassociation. Okay, remember sugar, right? We dump the sugar in there. Sugar does not disassociate. It dissolves, but it doesn't break into bits because sugar is not an ionic compound. It's made of covalent bonds. So disassociation and dissolving, not the same. Number 7 says explain how dissociated ions are able to conduct electricity. And this really just comes down to the fact that because they are broken apart, they can move independently. Okay, so when we had the thing with the light bulb on it and we put the salt in there, because the sodium and the chlorine were getting broken up, they could move independently from each other. All the chlorine could rush to one side, all the sodium could rush to the other side, and that's what conducts the electrical charge. Number 8, you can cross off, because that I specifically decided not to talk about. Not because it's dumb, it's just, it doesn't add a lot to our conversation of ionic bonds. Okay, number 9, which I believe is the last one. You should explain what an alloy is. So I can pretty much guarantee I will ask you to define an alloy. So an alloy is just a metal that has another element mixed into it to change its physical properties. The thing to remember, though, is that in an alloy there's no chemical bonds, right? The atoms... The atoms that are in the alloy are not chemically combined. They're not sharing electrons. They don't have electrons that have been transferred to make ionic bonds. Okay? They're just mixed together. It's a mixture, but that does change the physical properties a bit. They're not chemically connected. They're not chemically bonded. But as I said, you should know the difference between interstitial and substitutional alloys. Uh-huh. And then, like I said, you will probably see a list of different metals and alloys, and you should be able to pick out which ones are the alloys and which ones are not. Remember that, I mean, really, it's simple. Those should be gimme points because, again, if it's not on the periodic table, it'll be an alloy. Yeah, that's going to be a problem, as with most of this class. Well, we didn't get into defining which of the alloys were going to be substitutional and which were interstitial. You just need to know the differences between those. But I mean, I don't know. I didn't want to get into all that of going, okay, this actual type is. Yeah. Oh, if they're not chemically bonded, that's a good question. There is still a matrix that is formed between the base metal atoms, okay, and the other ones are just kind of stuck in between. It's the best, still kind of the way to think about it. So if you mix it too much where the base metal is too separated, then it won't hang together like that. But depending on the metal, then you're maybe just making the other metal the base metal. But if you mix too much carbon into steel, it'll fall apart. Last thing, don't forget, all exams have molar mass problems on them. Based on what I saw on the last test, there are a few of you that need to go back and review that just a little bit. Yeah. Okay. So actually, since we have time, why don't we throw one up there?
There we go. Nice.
We'll do that too. I mean, as with everything in this class, Hunter, I don't care if you actually do this. This is all just to help you out. All right, let's say you needed 12.6 moles of osmium. Yeah, I want to know what's that going to weigh? What's that going to weigh on a scale?
Yeah, it's like one like 55.
So I'll give you a minute to do that if you would like. Otherwise, I'll put up the other. Yeah, osmium's OS. Number 76. Yeah, we don't know how many grams.
Well, I can set it up. I'm just not going to solve it. I like it.
God dang it, I can't hit decimals right. So don't forget on the periodic table, all of these right here, I even put it up here so you don't forget, are in grams per 1 mole. So osmium has 190.6 grams for every 1 mole. We need 12 moles of it. The moles will cancel out. You multiply them together, and you get 2.396 kilograms. I did the conversion in my head because it's fun. I didn't say that, no. So you should get 2,396 grams. Okay? Let's do another one. Okay, if you had 76 grams of fluorine, how many moles would you have? And again, don't forget, these are all in grams per mole. Fluorine is F, yes. So its molar mass is 19 grams for every 1 mole.
76 divided by 19.
Oops.
Packers quarterback Aaron Rodgers collarbone
What's that? Yeah, the point is it's always going to be per 1 mole. You got to stick it in, you know, the right way so that you cancel out the right thing here. We're canceling out moles there. We're canceling out grams there. Nope.
Don't wait until it's all washed up and old. Then we'll get him fired, except for fire was actually good. Like, almost the table sheet.
Here's the question of the day.